3.
Welcome to the Powertrain Engineering Division here at Southwest Research Institute. My name is Robert Fanick, and I'm a principal scientist here, and I work in the emissions chemistry section. And part of what we do here in this division is to test cars and engines for exhaust emissions. But what I like to tell people instead is that I sniff exhaust for a living. So what we're going to do today is we're going to do an experiment, and this experiment is to try and show you how a scientist would go about developing ideas for their experiment, and then how you conduct the experiment, and then what you see is the result of doing that experiment. So the first thing that you start with is you start with a hypothesis. And the hypothesis is basically what your knowledge is of what the chemical and physical properties of things is, and you think about what question you have and what the possible result from doing that experiment. So our experiment today is to take this carnation and put it into liquid nitrogen. So first we'll start off with, I'll show you what liquid nitrogen looks like. Okay, that's liquid nitrogen, and I put the liquid nitrogen into this special container called a dewar. And so our experiment is to put the carnation into the liquid nitrogen and then see what happens. Now there's a lot of possibilities on what you might think could happen. One would be that this carnation might change color from this beautiful red color to some other color. Alright, so that's one possibility. Another possibility is that once I put it in the liquid, it might dissolve. So when I pull it out, all I end up with is just the stem. Another possibility may be that if I put it in there, it would catch on fire. So there's lots of different ideas on what could happen as a result of doing this experiment. So as I said, you start off with a hypothesis, and then you run your experiment, and you compare the result of that experiment to what your hypothesis is, and you either prove or disprove your hypothesis. And so once you do that, then generally that leads to other questions, which then leads to other experiments, so that you can continue learning and pushing back the frontiers of ignorance and superstition. So let's go ahead and put this carnation into the liquid nitrogen and see what happens. Alright, it's pretty well done. So let me pull it out, and you look at it, and it doesn't seem to have changed color. Fortunately, it didn't catch on fire, it didn't dissolve, and all that you really see is some of this vapor coming off of it. So let's see what happens when I hit it on the table, and it shatters just like glass. And what's happening there is there's water inside of the petals, and the water freezes as a result of putting it into the liquid nitrogen, because the liquid nitrogen is very, very cold, and it freezes the petals, and then when you hit it on the table, it shatters just like glass. But it warms up very quickly, and so now the petals are back to room temperature. So that's just one example of something that we can do with liquid nitrogen. Now I filled up this balloon. I just blew this up with air before I started to talk with you. And so I'm going to put this balloon into the liquid nitrogen, and let's see what happens when we put the balloon in there. Okay, let's get it nice and submerged. And you remember how big the balloon was before I put it in there. So let's see what happens now. Look how small that balloon is. All right. So what happened was the gases inside of the balloon were at room temperature, and so they occupied a certain volume. And once I got the gas very cold, the gas contracted, which contracted the balloon, and then as the gases began to warm up again, the balloon began to blow up, but it wasn't an even heating around the balloon, so some of it expanded quicker than others and caused the balloon to pop. So here's a third experiment that we can do. And I have this rubber tubing, and you can see how flexible this rubber tubing is. So what I'm going to do is put this rubber tubing in there and see what happens when I do that. And I don't know if you can see some of the liquid nitrogen is coming out of the end of the tube here. And when it stops spitting liquid nitrogen out of the tube, there it goes. It's pretty well frozen. And so then I take this out of the tube, and remember how flexible it was before. Okay, now it's very, very hard, and I can actually break the rubber tubing. So these are just a few of the experiments that you can do with liquid nitrogen, and what I was trying to demonstrate to you today is the scientific method and how a scientist goes about doing his work and trying to answer questions and solve problems. So thank you very much.
Go.
Okay, my name is Karen Carpenter. I'm the Assistant Director of the Fire Technology Department at Southwest Research Institute. My degree is in Fire Protection Engineering, so what we do is do fire testing and research. Okay, so today what I want to show everyone is how to use a fire extinguisher. Fire extinguishers are great for putting out small fires before they become big fires, but you always want to keep your safety first, so you don't want to put yourself at risk to try and use a fire extinguisher. Only do it if you can do it safely. Now there's 4 letters you need to remember to use a fire extinguisher, and you have to remember PASS, P-A-S-S. And what PASS stands for is pull, aim, squeeze, and sweep. So I'm going to demonstrate those steps to you so you'll know how to use a fire extinguisher to put out a fire.
And
so the first P is pull. When you get a fire extinguisher, it's going to have a pin going through it. And what that does is prevent you from accidentally squeezing it before you're ready to use it. So first step is P, pull. Okay, we've pulled the pin. Now we can use our fire extinguisher, and we're going to move on to the next step. What I'm going to do is light a pan of burning alcohol to show you how to put out a fire. Now I'm doing this in a test laboratory where we have controlled conditions, but you shouldn't try doing something like this at home. So now we're going to try and put out this pan of alcohol that's on fire. The next 3 steps are aim, squeeze, and sweep. We want to aim for the base of the fire. We don't want to aim for the top of the flames. We're going to aim for the bottom. Then I'm going to squeeze the trigger on the extinguisher, and I'm going to sweep back and forth across the flames. And that's how you use a fire extinguisher to put out a fire.